I welcome you all to this session of engine system and performance, and today we shall discuss about the measurement of both air and fuel flow rates, and then we shall discuss about the measurement of another important parameter, that is lift of needle, which is essentially related to the measurement of fuel injection in a CI engine. So, in the last class we have talked about engine performance, and then we have discussed about the measurement of an important parameter, that is engine speed. So, let us discuss about the measurement of fuel flow rate and air flow rate today, because these two important parameters are very important again to predict or to quantify the engine performance. So, we have studied in our undergraduate internal combustion engine course that air fuel ratio or fuel air ratio, this is very important. As such, care should be taken to provide stoichiometric air fuel ratio to the engine, essentially to have efficient combustion. Not only efficient, if the combustion is efficient, not only engine efficiency will increase, but also emission level can be reduced. So, let us discuss today first the technique of fuel flow measurement using a particular method. So, before going to discuss about this, let us recall that there are many measuring devices that we have studied in our undergraduate fluid mechanics course, and those devices are used essentially to measure volume flow rate of fluid or liquid, to be precise. So, we shall discuss today measurement techniques. Typically those are used to measure fuel and air, which are similar to what we have learned in our undergraduate fluid mechanics course. So, what is done, say for example, if we would like to measure flow rate of fuel or fuel flow rate to the engine. So, that means the amount of fuel to be injected to an engine. So, the most simple technique is to place a fuel tank. So, if we consider a fuel tank, and if we place this fuel tank on weighing balance, then if we can somehow record, then so place the fuel tank on a weighing balance, and then record the time which is required to consume certain mass of fuel by an engine, right. So, this is very simple method. If we know what we can do, that a stopwatch can be used for this. So, this is very simple method. So, this method is very old and simple. Now, just if we have one stopwatch and also pipette to measure the mass of fuel for certain amount of time that would be consumed by an engine. This method can be used to measure for both liquid and gaseous fuel. As I said you that a pipette and stopwatch can be used or may be used. Stopwatch can be used to measure the duration and pipette can be used to measure the amount of fuel that would be consumed by the engine. Now, what is important to mention in this context here that when the fuel is going to the engine, here a turbine pump can be placed. So, if I erase this, so one turbine pump can be placed in the line just to control the flow rate, and the rotational speed of the turbine pump is a measure of the flow rate of fuel. So, this is a turbine pump that can also be placed in the line which is connecting this fuel tank to engine, and the speed of this pump can be used or can be taken as a measure of the fuel flow rate. Note that using this device we can measure the volume flow rate of fuel instead of mass flow rate of fuel. Okay. So, this is very simple and old method that I have already mentioned. If we go to discuss about the technique which is also used to measure fuel, which is schematically shown in this slide, you can see that this is the calibrated volume. Now, fuel is coming from fuel tank. So, here we will be having one fuel tank. Okay. And there is a valve, and so in normal operation, so if we see this that or I can say when there is a need of normal operation of an engine. So, during normal operation this valve 1 is open. So, if I write here during normal operation. So, valve 1 is kept open, valve 1 is kept open. If we keep valve 1 open, then certainly what will happen, fuel flows from directly from tank to the engine. So, fuel flows directly from the tank to the engine, right, to the engine. So, this is the case. Now, then you may ask me a question, then if it is a case, then why do we need to have this particular volume, that is calibrated volume in this particular setup. So, you can see this particular volume which is again placed in between valve 1 and the line which is supplying or connected to engine cylinder or engine and intake manifold. Essentially it will go to engine, but this fuel will be supplied to the engine through fuel injectors. Okay. Now, this calibrated volume essentially is used to measure the amount of fuel to be supplied during measurement. We need to measure the amount of fuel should be or to be supplied to the engine. So, what is done that the vane pipe essentially should end. So, the vane pipe ends if the vane pipe, this vane pipe ends below the level of. So, if I erase this, so here we have fuel. So, this is fuel tank. if vane pipe ends below the level of fuel in the fuel tank, then care must be taken in filling of the calibrated volume. Okay. You can understand why I am telling this, rather you can have answer to this question. If vane pipe ends below the level of fuel in the fuel tank, then care must be taken to fill up this calibrated volume. So, you can ask this question yourself and try to have or try to get the answer from your own. So, you know this calibrated volume, what is done? So, this calibrated volume you can understand from the name itself, this is calibrated volume. So, what is done, you know, when this to measure the fuel flow. So, essentially what we need to do, we need to measure fuel flow rate using this setup or device. Okay. So, if we need to measure the fuel flow rate using this device, then valve 1 is kept closed, valve 1 is kept closed, and number 1. Number 2 is fuel is taken from the calibrated volume, to the engine. So, this is the step. Okay. So, fuel is taken from calibrated volume to the engine, valve 1 is remaining closed. Okay. Now, during the press of now essentially what, so this is these two steps are followed during measurement of fuel, and if we need to have or if we need to draw fuel from the calibrated volume to the engine during its measurement, certainly valve 2 has to remain open. So, 3 is valve 2, you know. So, if I write in the next slide, three is valve 2 should remain open, right. So, question is, if we go back to this previous slide, so in normal during normal operation, this valve 2 will remain closed, valve 1 should be kept open and fuel flows directly from fuel tank to the engine. Okay. So, that is normal operation or normal period of engine operation. Now, if we need to measure the amount of fuel should be taken by the engine per 1 hour or per 2 hour or per 1 minute. So, valve 1 is kept closed, valve 2 is kept open, valve 2 is allowed to open, and then calibrated volume will be filled by the fuel, and then engine will take fuel from the calibrated volume, and since the calibrated volume from the calibration itself we can measure exactly the amount of fuel will be consumed by the engine certain per unit time or per unit hour. So, per 1 hour rather. So, this is the method by which fuel flow is measured. Now, question is that this is okay for the measurement of fuel for SI engines, but if we need to measure fuel flow rate using the method that we have discussed for a CI engine, the problem is associated to the return flow. So, what is return flow? So, let me discuss here that problem associated with the measurement of fuel flow in a CI engine. So, this if this is the question or if we need to discuss this part. So, answer is this is related to the return flow of fuel. Let me draw the schematic depiction that will help you to understand this problem in a better way. If we go back to previous slide, you can see that this line is now connected to the injector of an engine, because essentially fuel should be supplied to the engine by the injector, by an injector. So, essentially for CI engines we use fuel injectors. Okay. So, this line is not that it is directly going to the engine, certainly it is going to engine, but the fuel will now go to fuel injector and from there fuel will be sprayed into the engine cylinder. So, in the injector you know that there is a needle, and probably you have studied unit injector or you know fuel injectors when you have studied internal combustion engine course. So, I will draw here a schematic depiction of the needle of an injector. Okay. So, this is the intake manifold, and so this is the fuel in to the injector, fuel from the tank. So, this fuel is coming from fuel tank, and if I draw now the needle is having one stem, so this is the fuel needle. So, this is injector needle. Now, you have studied this, and here fuel is sprayed, right. So, this is the intake manifold. Now, what happens you know that the fuel that comes from fuel tank that hits the needle, and then needle is lifted off, and as the needle is lifted off it is you know unseated. The normal tendency of the needle will be to remain seated here, and this is spring loaded needle. So, when the fuel is high pressure fuel is coming through this you know line, that high pressure fuel is trying to lift the needle, and the gap that will create through that gap fuel will be discharged into this intake manifold. So, this is the manifold. Okay. Now, so what happens you know that the movement of the needle that we will discuss today. So, essentially to measure the amount of fuel to be discharged into this manifold depends on the you know measurement of you know needle lift. So, that we will discuss you know later in today's class. So, what we can understand that the fuel that comes from fuel tank, that high pressure fuel will try to lift the needle, and as the needle is lifted, the gap that will be created, which is responsible for the pathway of fuel to be discharged into the manifold. Now, as I said you this is spring loaded needle. So, the natural tendency of the needle is to remain seated over here. So, it will again come down. So, when needle is again coming here and it is sitting on the guideways. So, then the fuel that will return from the fuel tank, that must be taken into account. So, basically pipeline would, high pressure line, if the gap is closed because of the normal or natural tendency of the needle, because needle will remain seated, then what will happen, that high pressure fuel should be again returned. So, the return flow must be taken into account to measure the fuel flow rate for or using this technique for the CI engines. So, this is one problematic issues. One way could be, but let me tell you one thing, typically fuel which is coming up to here, that will have little high temperature, because this part is also having high temperature. So, liquid fuel when it is coming in contact with surfaces having high temperature, liquid fuel will gain some temperature and that temperature will be higher. So, if we need to take that amount of fuel for the calculation of fuel flow rate, so care must be taken to reduce the temperature of the fuel to the supply fuel, and that fuel should be connected to the supply fuel line downstream the injector, essentially to calculate the exact amount of fuel flow rate. So, this is what is the problematic issue that I have discussed. And another problem is that I should tell you, while measuring this fuel flow rate using this technique, as I said you, these surfaces are having relatively higher temperature. So, liquid fuel might get evaporated, and that vapor block also can create some issues, problematic issues to measure the fuel flow rate. Okay. So, let us move to discuss about the measurement of air flow. So, we have discussed about fuel flow rate, then we have seen that a very simple and old method is to place the fuel tank on weighing balance and then to measure or to record the time which is required to consume certain amount of fuel by the engine. Then we have discussed about this particular measurement, that is fuel flow measurement using calibrated volume. We have also discussed one problematic issue, that is related to the flow of fuel in a CI engine. So, now let us discuss about air flow measurement. Measurement of air flow is not so easy, in the sense, because that it is very difficult to ensure that the amount of air that will be measured by any measuring device will be equal to the amount of air reaching the engine. Let me repeat once again, actual measurement of air flow, which is very important essentially to calculate air fuel ratio, but actual measurement of air flow is not so easy, in a sense that the amount of air that we will predict that okay fine, this engine will take this much amount of air during certain amount or for a certain period of time, that amount of air will reach the engine. So, amount of air measured by any measuring device is not equal to the amount of air reaching the engine, because air leaks into the cylinder, air leak out from the cylinder. So, air leaks into the engine cylinder and air also can leak out of the engine cylinder through valve glands. So, though we should take an effort to measure the amount of air which should reach the engine, but using certain using some device, but that that quantity may not be equal, rather will not be equal to the air that will be there in the engine cylinder. So, but let us discuss, and another problem issue is, so if I write here measurement of air flow rate. So, the first problem that I told you that it is not easy to ensure that the air or the amount of air that passes through the air flow meter reaches the engine. Actually, reaches the engine. So, this is one problem, right. Second problem is air flow is highly periodic if it is a single cylinder engine. Perhaps this aspect you have studied in your undergraduate internal combustion engine course, because we need to supply air through the intake manifold to the engine during intake stroke only. If it is a 4-stroke engine, remaining other 3 strokes are not associated with the air movement or air flow. So, it is highly periodic and also very if I write here 2, that air flow is unsteady. And periodic. So, measurement of air flow is measurement of air flow which is unsteady and periodic, because this is very common for any engine. As I said you that air is drawn into the engine cylinder during intake stroke, while remaining other strokes are not associated to air flow. So, this is highly periodic and also unsteady. So, the unsteadiness and periodic nature of air flow which is common for all engines, and if the measurement of air flow is unsteady. So, then because any measuring device we will be using, those measuring devices are suitable for steady flow measurement. So, knowing a priori that the air flow is unsteady and periodic, using any measuring device or any measuring devices, measurement of air flow is not very easy. Okay. So, that is very common. So, is not easy as measurement meters or devices are suitable for steady flow, that we steady flow analysis. So, these two problems we had discussed. Now, let us discuss about the setup or device that is shown here schematically. So, you can see that is this is manometer, this is orifice plate. Okay. So, typically what is done that this is called plenum chamber, large plenum chamber. So, this is plenum chamber. So, this plenum chamber is connected to the supply line. This is large plenum chamber which is connected to the supply line with an orifice plate at the inlet. So, this plenum chamber is connected to the supply line of air or air supply line which is going to engine with an orifice plate at the inlet. So, at the inlet of this plenum chamber we have one orifice plate, and see this manometer is connected across this orifice plate. So, probably you have studied in your fluid mechanics course, this orifice meter is used. So, now for the measurement of flow. So, what you can see when the air is coming in and the problem associated to this unsteadiness or periodic nature of flow can be alleviated if it is a multi-cylinder engine, but even then some degree of unsteadiness should be there, and also air is having less viscosity. So, the amount of air that will be drawn into the engine cylinder will be having some frequency, or it will resonate with the engine frequency. So, if that is the case, then actual measurement can be will be affected. So, what is done, this big or large plenum chamber is connected to the supply line, and this plenum chamber is having one orifice plate at the inlet. Now, when air is coming through this, certainly using this orifice plate or orifice meter we can measure the flow rate, we can measure the drop of pressure across the orifice plate, then we can measure the flow rate, but the positioning of this plenum chamber will help to ventilate all the unsteadiness that will be there due to air flow. So, as I told you that air will be drawn into the engine cylinder during intake stroke only, while there are several other strokes, 3 other different strokes. So, unsteadiness will be or unsteadiness can be dampened out together with that due to natural frequency of the engine, that air mass also will try to resonate. So, all these things can be dampened out using this large plenum chamber. So, this is what is important. Now, so this is water tube manometer, I should write. So, this is water tube manometer, Okay. So, now as I told you that measurement of air flow rate is not very easy, but on the other hand actual measurement of air flow rate is necessary. So, try to understand, in one hand we are saying that measurement of air flow rate is really difficult, or the actual measurement of air flow rate is difficult, primarily attributed to the unsteadiness associated with the flow together with periodic nature of the flow. But on the other hand we should measure air flow rate correctly, because then only we can ensure that the air flow ratio should be stoichiometric or not. So, the practice should be to measure the fuel flow rate correctly. If we go to the next slide. So, to measure the fuel flow rate correctly, let me tell you first, and then if we can calculate the air fuel ratio from the exhaust gas analysis, from the already we have calculated fuel flow rate. If we know the air fuel ratio from the exhaust gas analysis, then from there we can quantify what should be the amount of air or what should be the air flow rate. So, if I write here that most accurate method or means of evaluating the air flow rate is to measure fuel flow rate first and determine the air flow rate by calculating air fuel ratio from the exhaust gas analysis. So, this is what is important, that is why I have mentioned here. So, finally, we shall discuss about the measurement of needle lift. So, if we go back to our previous slide, wherein we have shown this injector needle. So, try to understand that measurement or accurate measurement of fuel flow rate is necessary for the accurate measurement of air flow rate that we have discussed now only. And also if we need to that means if we need to have accurate measurement or if we need to measure fuel flow rate accurately, what we need to do is we need to measure the lift of this needle, and today we shall discuss about one technique or one method which is used to measure the needle lift. So, if we write here that measurement of needle lift. So, let us discuss about measurement of needle lift. Right. So, as I told you that which is lift of the needle in the injector must be measured accurately, essentially to measure the fuel flow rate, which in turn will be used to measure the air flow rate accurately. Okay. So, measurement of needle lift. So, if we redraw this, just I am drawing once again. If this is the needle, then this is the guide ways, So, that is fuel flow, through this also fuel will flow from fuel tank. If we ideally what is done, fuel is supplied from both sides, so that the lift movement should be symmetric and also uniform. So, this is the needle. So, this is the needle. Okay. And so, this needle lift, is very important. As I told you that natural tendency of this needle will be to remain seated on this guide ways. So, this is spring loaded needle. And high pressure fuel that comes from the fuel supply line forces this needle to lift off, and then only this liquid fuel comes or is discharged into this manifold or tube, or if it is engine cylinder. Now, this lift should be or needle lift should be measured accurately to measure the fuel flow rate. So, let me tell you the method. So, if I write here that, so the moment at which needle is lifted from this guide ways is the beginning of fuel injection, right. So, number 1, the moment that the needle is lifted from its seat or guide ways is the beginning of fuel injection, right. Number 2 is, and when needle again seated on the guide ways or lift hits 0, fuel injection stops. Okay. So, this is the method. So, essentially we have to measure the movement of this. So, these are the guide ways, guide way. So, this is also guide way. So, this is what is done. Now, question is to measure this needle lift, to measure the needle lift, a frequency modulated system is used, frequency modulated system is used, and this system, this frequency modulated system is based on or utilizes the fact that changes in inductance that the changes in inductance of a coil should be recorded. That means, this frequency modulated system that changes the inductance of a coil. So, essentially this particular system is reliant on the fact that the inductance of a coil should be changed and that should be measured or recorded. Okay. So, what is done, what is done to do this? First step is or I should not say step. One is an armature is connected to the injector needle. Right, to have this. So, basically our objective is to measure this lift of the needle, and to do that we will be using frequency modulated system which record the changes of inductance in a coil. And what is done, essentially an armature is connected to the injection needle. Then number 2 is the armature extends, this armature extends halfway into the coil. The coil of the induction of that particular coil should be recorded. So, the armature extends halfway into the coil, and number 3, the coil forms part of a tuned circuit that resonates at close to 2 megahertz. Okay. So, now as the needle moves up, let me write floor point. So, as the needle moves off or lifted off, right, what will happen? As the needle moves off or lifted off, you know what happens, you know that due to the motion of the needle stem, inductance of the coil changes with a consequent change in resonant frequency. So, essentially you are trying to measure the change in resonant frequency or change in induction in the coil. As the conduction will change, it will change the resonant frequency also, that is why it is frequency modulated system. Okay. So, this frequency modulation, so essentially what will happen, you know that we can see the frequency will be changed and then the frequency, if we go back to the previous slide. So, this is number 5, the frequency modulation is converted to an analog voltage which is or that is proportional to needle lift in a uniformly wound coil. So, coil is uniformly wound and from there we can measure the needle lift. So, let me go back to the previous slide. This is essentially stem. So, stem of the needle, right. What are the steps? We are using frequency modulated system which essentially relies on the change in induction of a coil and that should be recorded, right. So, what is done? Armature is connected to the injection needle through the stem and that armature extends halfway into the coil. So, there is a coil which is uniformly wound and halfway of the coil. So, as the needle is lifting off, so the coil forms part of the tuned circuit that resonates at close to 2 megahertz. The coil will resonate. Now, as the needle moves up or lifted off, that essentially due to the motion of the needle. So, when high pressure fuel will try to force the needle to move off, that will be that will help the armature to also move and the inductance of the coil will change because armature is halfway into the coil, and when the induction will change, it will result in a change in resonant frequency, and this resonant frequency or frequency modulation is converted to analog voltage that is proportional to needle lift. So, in a way we are trying to understand the amount of needle is lifted by the forcing due to fuel or high pressure or pressurized fuel. So, this lift in a sense will try to help us to understand the amount of fuel should be supplied, how much the needle is getting lifted, what would be the duration. Following this we can calculate the amount of fuel should be injected or supplied to that line. So, to summarize our today's discussion, we have discussed about several methods of fuel flow measurement, then we have discussed about airflow measurement method, and also we have discussed about the measurement of needle lift, which is very important to measure the accurate fuel flow rate, which in turn will help to measure accurate airflow rate. Also we have discussed several problems associated with the measurement of both fuel and air into the engine cylinder. With this, I stop here today and we shall continue our discussion in the next class. Thank you.